Good afternoon, all. In this lecture, we are going to discuss about greenhouse effect. The subject name is power generation process, and already we have discussed many points about power generation process, like different power plants, their advantages and disadvantages, and tariff and what are the tariffs. So, in and we have already discussed about non-renewable and renewable sources. So, this is the topic which is your greenhouse effect. So, course objective of this subject to introduce the students of the basic theory of renewable energy sources and to familiarize the students to the principle of greenhouse effect. Learning outcome. After this lecture, I'm expecting from students that students will be understand the greenhouse effect and its advantages. Its disadvantages on ecosystem. So these are the this is the greenhouse effect. So what is greenhouse effect? You can see that from the picture it is like some sunlight that hits the earth and reflected. Then it's reflected. This sunlight is coming here and some it hit the earth and then reflected. So when this light is reflected, there is some gases like carbon dioxide and other gases in the atmosphere uh, trap heat and keeping the earth warm. Okay, there are some gases which get heated when sunlight is coming on the earth, and it increase the temperature of the earth. So the sun's energy reaches earth through radiation heat traveling through space. So radiation from the sun and this is reflected solar radiations, and some heat energy is reflected as emitted from the surface. So what is insolation? So the incoming solar radiation energy from the sun that reaches to the earth, that is insolation. So when and where does the most intense insolation occur? So the daytime in the afternoon, the insolation is intense, and time of year is June 21, near the equator. So this is your insulator, and this is the surface more area diffuse receiving isolation, and these are the sun rays which is arriving parallel to the earth directly. So this is more concentrated, annual 2.5 times more energy than poles at this place. So more diffusion is here, that is oblique. So this is all about that how sun rays affect the earth and at which place its intensity is more than other places. Now, how much solar radiation reaches earth? The earth's surface only absorbs 51% of incoming solar radiation. Suppose this is your sun and the sunlight is coming. So 51% is observed by the earth, 30% is reflected by earth's surface and atmosphere, and 19% is absorbed by the atmosphere. So what is condensation and evaporation? This is 51% is used for the Condensation means that and evaporation, that is used 23%. For infrared radiation, this is used 21%, and conduction and convention, this is used 7%. So incoming solar radiation is equal to 100%, and 19% absorbed by clouds, atmosphere, and 30% reflected from clouds, atmosphere, and earth surface. So energy is transferred from the earth's surface by radiation, convection, radiation evaporation, and water condensation. So ultimately, the sun's heat and Earth's energy transfer is a major cause of weather. So what is your greenhouse effect? So the process by which atmosphere gases absorb heat energy from the sun and prevent heat from leaving our atmosphere. So the process by which atmosphere gases absorb heat energy from the sun and prevent heat from leaving our atmosphere. In other words, greenhouse gases trap heat energy and keep it close to Earth. So three main greenhouse gases. One is your carbon dioxide, methane, and water vapor. So the greenhouse effect is it is easily understand by this picture as that the sun is giving us solar light. So some of them is used for solar radiation, that is your reflected heat. But when it comes into the come into the uh, carbon dioxide and other gases, it increase the temperature. This is your radiate heat, re-radiate heat, which is again coming to the earth after heating the gases or increasing the temperature of gases. Increasing greenhouse gases absorb and re-radiate heat. So this is all about your greenhouse effect. Now, next point is your the greenhouse effect works like a greenhouse and so is the greenhouse effect good or bad? So it is necessary for life. So this is good. It keeps our climate toasty warm and prevents it from fluctuating too much. It is bad when there are too many greenhouse gases and the climate gets warmer. That is called your global warming. So in today's scenario, global warming is a point which must be considered and because day by day the temperature of earth is increasing and we people are not aware about that, and even we are not many organization and government are trying to improve this uh, global warming or sorry decrease the global warming. So we must be aware about this global warming. We must plant some trees and we must not use those things which pollute our environment or which release carbon dioxide more, because this increase the temperature of earth. So uh, consider the greenhouse effect on other planet, that is your Mercury and Venus. So, what is global warming? So, an increase in average global temperature, that is your global warming, and it is caused by an increase in greenhouse gases in the atmosphere. So, basically, global warming is the increasing the temperature of the gases which is present in the atmosphere. Some of them are good that it keeps our environment warm, but it will it will increase continuously and the temperature of earth will increase and it will not good for our ecosystem. Everything will be imbalanced and we have to suffer for that. So this point must be considered and is a big issue nowadays uh, in overall world. So what causes an increases in greenhouse gases? One is your carbon dioxide is added to the atmosphere when people burn coal, oil, gasoline, natural gases, fossil fuel for transportation, factories, and electricity. So this is your greenhouse effect. What else causes an increase in greenhouse gases? So deforestation is we day by day cutting our trees. So it is majorly affecting our environment, our health, our system. So, because if you are continuously cutting the trees, then you will not able to one day you will not able to get the oxygen, and you have seen that this scenario in the corona period. So people were running here and there for oxygen, and it is very difficult to survive. So deforestation must be controlled, or the clearing of forest also increases the amount of carbon dioxide in the air, because in photosynthesis plants take in carbon dioxide and remove it from the atmosphere. They make oxygen. So what else causes an increase in greenhouse gases? So these are volcano fires and respiration, that increases the greenhouse gases. And so you can see that if you talk about thermal power plant and you burn the coal, then carbon dioxide is released in the atmosphere. It is very dangerous for us. So it must be reduced. That's why we are coming on renewable energy sources, which is pollution free, like solar power plants and hydropower plants and other things like wind power plants. So when combustion is there, there will be carbon dioxide. Okay? So in volcanoes, there are large number, very large combustion occurs, so very large amount of carbon dioxide is released in the atmosphere. And there is combustion of fossil fuel, which is also responsible for you know uh, greenhouse effect. And there is assimilation by plants and animals, and plant respiration, animal respiration, assimilation into soil, assimilation by phytoplankton. So these are the uh, causes of increasing carbon dioxide in the atmosphere. So we must be take care of this. Next point is here, what else causes an increase in greenhouse effect? So methane, which is produced when garbage is buried in landfills from animal waste. So these are the methane which pollute the environment from other natural sources. So these are the methane sources: insects, oil and gases, coal mining, landfill, other domestic animals, biomass burning, rice fields, and wetlands. So these are the causes of increasing methane. So we have to be take care about this also. And there must be some methods which can reduce the production of methane. So next point is our renewable energy sources. So now we will discuss renewable energy sources. Minus Xc. So by these formulas, you can easily calculate the impedance of your AC circuits. Now we come to the power triangle to understand the power factor. So from this diagram, you can see that this horizontal component is representing your I cos phi, and this vertical component is represented by I sin phi. Okay. So where I cos phi is your active component current, and I sin phi is your reactive component current. Okay. So from this triangle, you can see that this is your active power, which is represented by P is equal to VI cos phi. Okay. If you multiply this voltage by these currents, okay, you will get this triangle, and the active power is equal to VI cos phi, and the reactive power is represented by Q is equal to VI sin phi, which is your this vertical portion, and this represent your apparent power, which is S is equal to VI. So this is your active power, this is your reactive power, and this is your apparent power, and phi is your power factor angle. So the angle between voltage and current, the angle between voltage and current is represented by phi, and phi is your power factor angle, and cos phi is your power factor. Okay, so we need to understand this cos phi, and we need to improve this component, which is your cos phi. So I cos phi is your active component of current, and I sin phi is your reactive component of current, and V and I are circuit voltage and current respectively. So impedance triangle can be represented by S is equal to root of P square plus Q square, where S is your apparent power, P is your active power, Q is your reactive power. And the total impedance can be represented by R square plus X square, root of these two. So this is the diagram. Horizontal vector shows the resistance, vertical is shows your reactance, and this is show your impedance. So Z is equal to root of R square plus X square. Now we have to understand what is your active power, what is your reactive power, and what is your apparent power. So active power is always represented by P, and the power which is actually consumed or utilized in an AC circuit is called active power or true power, which is represented by watt. So it is the active component of current and circuit voltage. So P is equal to VI cos phi is your active power, where P is your active power component, V is your voltage, I is your current, and cos phi is your power. Okay. So next is your reactive power, which is represented by Q, and the power which flows back and front or reacts upon itself is called as reactive power or wattless power. Okay, it is not actually have watt, it is only have reactive component. So the unit of reactive power is in VAR, voltage ampere reactive. So it is the reactive component of current, which is represented by I sin phi, and circuit voltage is V. So Q is equal to VI sin phi. Now we come to the next point. Actually, reactive power is very important for the power factor improvement. Okay. So P is equal to VI cos phi is your active component. Q is equal to VI sin phi is your reactive component. Now, the product of circuit voltage V and the circuit I in an AC circuit is called apparent power, which is always represented by voltage amperes. Okay. So now I think it is clear to you that active power is the power which is consumed by the customer or consumer, and reactive power that flows back and front or reacts upon itself, and it is wattless power, that is your reactive power, and it is represented by Q. So this is all about your active power, reactive power, and apparent power. Let's come to the next point, that is your tariff. So before understanding tariff, first we have to understand the cost of electricity. Suppose, for example, you are getting electricity in your house from you can say grid. So you are charging for you are charging for the electricity. Now, the charge which you are paying, how the grid decide? Okay, so the charge which you are paying and the electricity charge which you are paying in terms of units. Okay, the unit which you are consuming Suppose if you are using 10 unit in a month, then you have to pay 10 multiplied by the charge which is decided by your grid station. Now the point is the cost of unit. How can we decide the cost of unit? So this is your tariff. So the rate or charge at which electrical energy is supplied to a consumer is known as tariff. And it includes cost for generation, investment cost for transmission, distribution, operation, maintenance, and losses, along with penalty for consumers at low power factor. If so, you can see that the cost of electricity is also depend upon the power factor. So this is most important to understand that how can we improve our power factor, because your rate of charge or rate of charge of electricity is depending upon your power factor also. So the charge of electricity can be divided into many parts, like the type of tariff can be divided into simple tariff, flat rate tariff, block rate tariff, two-port tariff, maximum demand tariff, and power factor tariff. In the next lecture, we will definitely discuss about the different types of tariff. Okay, so these are the different type of tariffs. Why by using these methods, the charge of electricity can be decided. Now, so first we have to understand that what is your power factor tariff. So maximum, if you talk about your kVA maximum demand tariff, this is always calculated by this formula, kilovolt ampere. Volt ampere is the your apparent power, okay, and which is equal to kilowatt upon power factor. Active power upon your uh, cos phi. So P upon cos phi is equal to S, which is your S. Okay. Now, kilowatt hour and kVA RH tariff. So kilowatt RH is your, reactive power, which is decided by this formula P upon cos phi into sin phi. So, sliding scale or average power factor tariff. So, here the average power factor tariff is taken as 0.8 lagging. If you want to consider the power factor, so average power factor which is considered, that is your 0.8. If your power factor goes less than 0.8, then you will be penalized. And the power factor, if it is going above 0.8, then this is that you will get discount. So here the average power factor is taken as 0.8 lagging. If the power factor is less than 0.8, then the consumer will be penalized. If the power factor is greater than 0.8, then the consumer will get discount. Okay. Now there are different types of loads. So before understanding the power factor, we have to understand the different kind of loads. So one is your resistive load, the another one is your inductive load, and third one is your capacitive. So these load are considered for the calculation of power factor. If your load is resistive, then you can see in the diagram that the voltage and current will remain in the same direction. Okay. So if the load consists of resistance, then the load is a resistive load and voltage and current are in phase. So there is no angle between voltage and current. So which results unity power factor. As you know, power factor is represented by cos phi. Phi is the angle between voltage and current. In resistive load, the angle between voltage and current is zero because both quantities are in same phase. That's why phi will be 0 and cos phi will be 1. So when load is resistive, then the power factor will be maximum and it consumes only active power supply. Okay. Now let's come to the next point, which is your inductive load. Okay. So what is your inductive load? If the load consists of resistance and inductance, then the load is your inductive load. And in inductive load, current always lag the voltage by some angle. So here I'm taking this, the angle is phi. And the problem is with this angle phi because if your load is inductive, there will be always be some angle between voltage and current. Okay, it may be a 20-degree, 30-degree, 40-degree, 50, 60, or 90-degree. So the angle between voltage and current is always considered as your power factor angle. And in the case of inductive load, there will always be some angle between voltage and current. Okay, so this is your inductive load, and it always consume both active and reactive power. And the angle between voltage and current, which results lagging power factor because current is lagging. So this always leads to lagging power factor if your load is inductive. So now I think you are able to understand your resistive load and inductive load. There are some example that the lamps and resistance heater is always comes into the category of your resistive load. If you connect your induction motor and transformers because they have coil, so they will consume some reactive power, and this is considered as your reactive load. Now we come to the next point, which is your capacitive load. So in capacitive load, you can see that this is your voltage and this is your current. We are taking voltage on x-axis, and there is some angle between voltage and current which is denoted by phi. And you can see over here that the current is leading the voltage. So if the load consists of resistance and capacitance, then that load is a capacitive load. So here voltage and current are not in phase, voltage and current, which results leading power factor. So it consumes both active power and compensate reactive power. Our examples are capacitor and synchronous condenser for power factor corrections. So this is your capacitive load in which you can easily, by using this capacitive load, you can easily control your power factor. We will discuss in our next lecture that how can we improve the power factor. So I think now you are able to understand that what is your power factor and how it depends on your resistive load, inductive load, or capacitive load. For example, there are two examples. One is your induction motor and another one is your overexcited synchronous motor. So you can see in the diagram, when a induction motor is connected to your load, this is your generator and this is your supply which is connected to your induction motor. So you can see from the diagram that it is consuming kilowatt and it also having kVAR which is lagging. Okay. So there will be a reactive power and there will be some power factor. Now, this is your overexcited synchronous motor in which it is consuming kilowatt, but it is supplying leading kVAR. Okay. So this is your overexcited synchronous motor. This is your lagging and this is your leading. Now, what is your power factor? So I think now you are able to understand that what is power factor. So power factor, the cosine angle between voltage and current in an AC circuit is considered as power factor. And the ratio of resistance and impedance of an AC circuit is also considered as power factor, and the ratio of true power and apparent power is also considered as power factor. So the voltage and so the ratio of resistance and impedance of an AC circuit we have already done, that is equal to R upon Z, which is equal to cos phi. Okay, so this is the formula of power factor. If you take true power and apparent power, like cos phi is equal to P by S, is also represented by your power factor. Okay. Now we come to the point that you have resistive load. So in the case of resistive load, you can see over here that the power factor, the angle between voltage and current is 0. So the power factor phi is 0 and cos phi will be 1. So for resistive load, the power factor is your unity. If you talk about your inductive load, here you can see that the current is lagging by some angle of phi. So for inductive load, the power factor is lagging. If you talk about capacitive load, for the capacitive load, power factor is leading. So the power factor is leading by some angle of phi. Now there are some factors, power factors or some common loads which has the power factor for example, we take incandescent lamp. It has power factor 1.0 because it is purely resistive. If you are taking arc lamp, that it has power factor of 0.3 to 0.7. If you are taking the power factor, which is if you are taking neon lamp, if your load is connected with neon lamp, then the power factor will be from 0.4 to 0.5. If you are taking fluorescent lamp, then the power factor will be 0.6 to 0.8. If you are taking resistive heaters, then the power factor will be 1.0. If you are taking induction heaters, then the power factor will be 0.85. If you are taking arc furnaces, then the power factor will be 0.85. If you are taking induction furnace, then the power factor will be 0.6. If you are taking arc welding, then the power factor will be 0.3 to 0.4. If you are taking resistance welding, then the power factor will be 0.65. And if your load is your inductive, then power factor will be 0.8. Okay, so these are some loads by which you can easily understand the power factor. Okay, so maximum power factor is for this lamp and resistance heater, and induction motor it is 0.8, and arc welding it is very less, which is 0.3 to 0.4. So these are the different loads. You can see the power factor for these loads. Okay. Now, what are the causes of low power factor? Because low power factor is just because that there are some inductive load. If you are using induction motors, transformers, arcing or induction heating furnaces, lamps, arc lamps, then your power factor will be low. So these are some causes of low power factor. Number one is your induction motor. Second one is your transformers. Third one is your arc or induction heating furnaces. Fourth is your arc lamps and electric discharge lamps. And last one is your variable load. So these are the causes of low power factor. Now, there are some disadvantages of low power factor. So disadvantages of low power factor is the rating of alternator, transformer and switchgear increased in kilovolt amperes. The size of the conductor increases. The power loss in the system increases. Poor voltage regulation. System efficiency decreases. Penalty if power factor tariff, and overall cost increases. So these are the some disadvantages of low power factor. If you are having low power factor, then you have to face these challenges. Okay, if power factor is low, then rating of your alternator, transformer and switchgear will be increased. Switchgear means your circuit breakers and relays, which you are using in your grid. And the size of conductors will also be increased, and the power losses will be high, and voltage regulation will be less, system efficiency will decrease, and if your tariff is dependent on your power factor, then you must be charged some penalty, and the overall cost of electricity will also increase. So it is very much needed to correct the power factor. Now, there are some, methods by which you can correct the power factor. So, poor power factor is most commonly corrected with the insertion of capacitor or a capacitor bank at the desired location to perform the correction. So the capacitor provides current that leads the voltage. This combines with the current associated with the magnetic fields that lags the voltage and cancels it out if sized correctly. Now, synchronous machine is also can be used to improve the power factor, okay, because it supply your leading current similarly to a capacitor, and the power factor is always better power factor improvement is always depends on proper selection of size, location and methods. If you are not selecting proper size for power factor correction, if you are not selecting proper location for power factor correction, if you are not selecting proper method of power factor correction, it will not be beneficial. So these are the 3 points by which we can correct the power factor. So size of the capacitor can be decided by your system voltage. And there is some calculations by which we can decide the size of your capacitor's bank. So you can see that the capacitor current IC is equal to I1 sin phi 1 minus I2 sin phi 2. So I1 sin phi 1 is the reactive component before correction, and I2 sin phi 2 is the reactive component before correction. So the capacitor current IC is equal to I1 sin phi 1 minus I2 sin phi 2. And IC is equal to V upon XC. So XC is equal to 1 by omega C. And omega is equal to your 2 pi f. So by this calculation, you can easily calculate the size of the capacitor which is needed for power factor correction. So for example, if your system voltage is 3.3 kilovolt, 6.6 kilovolt, then you need 75 kVAr capacitor bank which will supply 75 kVAr. If you are having 11 kV, then the capacitor which is needed, that is your 200 kVAr. If you are having 22 kV kilovolt system voltage, then you required 400 kVAr. and for 33 kV you need 600 kVR. This is the minimum rating of capacitor bank, and by this formula and this calculation you can easily calculate that how much capacitors is required for power factor correction. So you can first you have to decide the location of capacitor, series connection and parallel connection. These are the types of capacitor, and by which you can decide the location of capacitor where you have to locate the capacitors. Next is your, there are another methods which is your power factor correction. One is your static capacitors, synchronous condensers, and phase advanced condensers. So we will discuss about these method in our next lecture. And there are some few, this is the reference of this lecture. You can go through these references. Okay. Now these are some MCQs which is based on this lecture. So first, what is power factor? Is a ratio of, already I have told you that the power factor P is equal to, power factor is equal to cos phi, and this is the ratio of true power to apparent power. True power is your P and apparent power is your S. And this is the right answer. I have already told you P is equal to VI cos phi and S is equal to VI. If you divided your true power by the apparent power, you can easily get your power factor, which is equal to cos phi. So P upon S is equal to cos phi. Next one is your power factor can be mathematically expressed as. So power factor can be mathematically expressed as P upon Q, where P is your active power, Q is your reactive power, Q upon P, P upon S, S upon P. So P upon S can be mathematically, power factor can be represented. So third option is the right answer. Now the second next question is your, the power factor angle of a purely inductive circuit is, purely inductive circuit, the power factor is your 90 degrees. So the options are given 45 degrees, 60 degrees, 75 degrees, and 90 degrees. So the right answer is your fourth option, which is your 90 degrees. Next, in a load compromising of resistance and inductance, in a load comprising of resistance inductance, if your load is consist of your resistance as well as it is having inductance, then load current lags voltage, load voltage lags current, both are in phase, any of the above. So you know in the in your inductive load, the current always lag the voltage. So load current will always lag the voltage. So load current lags voltage. Now the next question is, the maximum value of power factor is. So the maximum value of power factor can be calculated. Power factor is equal to cos phi. Cos phi will be maximum when phi will be 0. So the cos phi have maximum value 1. So the maximum value of power factor is your 1. The next question is, the power factor of capacitive circuit is. As we know, in the capacitive circuit, the current always lead the voltage and power factor is always calculated in the terms of current. So it is leading power factor, and the answer for this question is your first option, which is your leading. Now let's come to the next question, which is, a circuit having poor power factor will draw. Suppose a circuit which have your poor power factor, it will always draw the high current. So options are given: no current, low current, normal current, and high current. So the right answer is your high current, and it will always draw on the high current. Next question is, the power factor of purely inductive circuit is. So the power factor of purely inductive circuit is, If your circuit is purely inductive, and you know in inductance the current is always like the voltage, so the for inductive circuit, purely inductive circuit, the power factor will be lagging. So the options are given: leading, lagging, both of these, any of these. So the power factor will be lagging. So the second answer is the right answer. Now, next question is, a 500 kVA circuit drawing 200 kilowatt. So P is your, uh, P is your active power, and circuit rating is given 500 kVA volt amperes, and an inductive load requires how much capacitance to obtain unity power factor. So you can easily calculate this question, and how much capacitance to be obtained. This is your 300. Okay. Now, improving power factor. So how can we improve the power factor? Reduce current for, if you want to improve, if you are improving the power factor, then what will be the effect of your circuit? It reduces current for given output, it increases loss in the line, increases the cost of equipment, all of the above. So A is the right answer. It reduces current for given output. So this is all about your power factor. And the last question is, power factor is a ratio of true power to apparent power. So this is all about your power factor. And in the next lecture, we will discuss about the different methods by which we can improve your power factor. Okay, thank you.